9.6, reverse distribution, GCF. Learning objective. I can recognize when something has been distributed and undo it. So once distribution has occurred, how do we undo it? To answer this question, first we need to know, what is distribution? What are we doing? Which operation is it? It's multiplication. So what's the opposite of that? Division. So how do we undo distribution? With division. Okay. So let's do some examples because it's a lot easier to see in examples. So if you were given 8y plus 16xz, what was distributed? And how do you know? So this problem we actually did in 9.4 right there. So you can see what was distributed in was the 8. So let's go back to our page that we're working on. So what was distributed? The 8. And how do you know? So we know on this one because we have done this problem before, but how would we be able to look at this and know? Well, what we're doing is we're looking for what we call the greatest common factor. Okay, so we're going to look at what they have in common. So first we're going to check variables. Do they have any variables in common? No. So we know that what we're distributing doesn't have any variables. Okay, and then we look at the numbers. And we see an 8 and a 16. And we're trying to find a common factor between 8 and 16. So what I like to do is I like to list out what are all of the factors of 8. 1 and 8, 2 and 4. And that's it. And then I like to do it for 16. 1 and 16, 2 and 8, or 4 and 4. And then I look for, okay, what do they have in common? Well, they both have a 1. They both have a 2, they both have a 4, they both have an 8. And I'm looking for the biggest one of those, okay? So it's an 8, it's the biggest one. So how do we know that 8 was distributed? Well, because it is the greatest, biggest, largest, greatest common factor. Okay. All right, let's look at another example. So we're going to have 2x squared plus 4x plus 4. So we're going to do the same thing. We're going to look at our variables first. And we have to look at every single term. We have to look at this one, and this one when we're doing this. So let's check variables first. Do any of these have the exact same variable? So the first two have an x, but the last one doesn't. Okay, so our greatest common factor is not going to have a variable again. And then we look at the numbers. We have a 2, a 4, and a 4. And we're trying to find the greatest common factor. So we look at a 2. So the choices for 2 are 1 and 2. And for 4, it's 1 and 4 or 2 and 2. So the biggest one that they have in common is this 2. So we know that the 2 was distributed. So this is what we call pulling out the greatest common factor. Okay, so step 1 is to do exactly what we've been doing. Determine what all of the terms have in common. Now, step 2 is how we're actually going to pull it out. And we're going to divide each of the terms by that. Okay, so let's try it on this one up above. Okay, so we're going to divide each term by 2 because that's what was distributed. So we're going to take this 2x squared plus 4x plus 4, and we are going to divide by 2 on every single term. Now what happens is that 2 divided by 2 is just 1, so that's going to go away. You're going to have x squared. 4 divided by 2 right here can reduce or simplify to 2, and our x hangs around. And then 4 over 2 here also simplifies to 2. And that's what we would have left after we distributed it. Okay? Now, we put that all in parentheses. And then we write whatever we divided by out in front. Okay? So the 2 that we're dividing by on all of these is going to end up out here. And then all of this leftover stuff ends up here. Okay, so all we're doing is saying, okay, a 2 was distributed, so we need to pull it back out. And you can always double check this, right? You can look and see, if I distribute that 2, am I going to get back to what I started with? So 2 times x squared is 2x squared, 2 times 2x is 4x, and 2 times 2 is 4. Is that what we started with? Then we have done this correctly. Okay. All right, let's do some more examples. Okay. So here's an example 3, and I want to see the steps. So step 1 is to determine what every term has in common. I like to look at variables first. So we're looking here and here. The 4 doesn't have a variable, so they don't have any variables in common. Okay. And then we're going to look at the numbers, 4 and 4. What do 4 and 4 have in common? Well, a 4, right? So we're going to take 4x plus 4. We're going to divide every single term by 4. Okay, so when we do that, 4 divided by 4 is 1 and will go away, and 4 divided by 4 is 1 and will be a 1. So we have x plus 1 left over after we divide that. But because we were dividing by that 4 needs to be on the outside. So this would be your answer. Okay. Now, let's double check our work here. 4 times x is 4x. 4 times 1 is 4. Is this what we started with? Yes, it is. So that is the correct answer. Okay. All right. So I want you guys to go ahead and try this example on your own. If you get stuck, I will go over it at the very end of this video. Okay. But I want to do this first. I can now distribute and undo distribution. Distributing is multiplication. So to undo it, we use division. Okay. All right, so I want you guys to go ahead and try this one out. Okay, so pause the video, make sure you've done this before you go on. Okay, so first we have to find what they have in common. So first we look at variables. Got an x squared, an x, and nothing. Because this one has nothing, there is no variable in our greatest common factor. So then now we look at numbers. We've got 3, 3, and 9. So 3 factors are 1 and 3. 9 factors are 1 and 9, or 3 and 3. The biggest one that they have in common is that 3. So that's what we're going to take out. Okay, so we're going to take our 3 out. Now, we had 3x squared plus 3x plus 9. So we're going to go ahead and divide each term by 3. Now, 3 divided by 3 is 1. That goes away. 3 divided by 3 is 1. That goes away. 9 divided by 3 reduces to 3. So we should have a plus 3 on the end there. So once we've done these problems, x squared is what's left here. X is left here. You could write 1s in front of these. That's fine. There's nothing wrong with that. And then 9 divided by 3 left us with a 3 here. Okay, so we can double check, as we always should. So let's go ahead and distribute it back in and make sure we get what we started with. 3 times 1x squared would be 3x squared. 3 times 1x is 3x. And 3 times 3 is 9. Sure enough, that's what we started with. So this is the correct answer. Okay. If you have any questions, let me know. The 9.6 assignment is in Canvas for you.